Hi guys, it's Miss Elkins here. I want to talk to you a little bit about algebraic representations. First of all, I want to look closely at this graph, and hopefully you can see it from where you're at. Let's look at the name of the graph. The name of the graph in this picture is cakes made versus sugar used. That's the name of this graph. And if you can look down here on the x-axis, the horizontal axis, it says number of cakes made. And then on the y-axis, the vertical axis, it says sugar used in cups. So let's compare here and see what's happening if you make 0 cakes. Of course you'll use 0 sugar. And if you make 1 cake, it looks like maybe 1.5 cups of sugar. But based on what we know, let's first say, what is this graph about? Well, it's about number of cakes made versus the sugar used. What's the independent variable? Well, the independent variable is always the thing that's listed on the x-axis. In this case, it's the number of cakes made. Okay, what is the dependent variable? Well, that's always on the y-axis. That's the amount of sugar used. All right, and can we make a function table from this? Of course we can. We look closer at the graph, we find some points on the graph, and we put them in the table. It looks like very clearly here that for 2 cakes, there's 3 cups of flour, which makes my original estimate correct, that 1 cake is 1.5 cups of flour. So we can make a table completely matching this graph. Okay, so let's do that. Let's say cakes made versus sugar used. And I already told you that if you make 0 cakes, you will use 0 sugar. That's how we know what type of relationship this is. And we'll just go by the points that are on the graph. If you make 2 cakes, it takes 3 cups of sugar. If you make 5 cakes, how many cups of sugar would that be? A little less than 8, right? What's 5 times 1.5? Well, I don't know. Let's see. 1.5 times 5. 5 times 5 is 25. 5 times 1 is 5 plus 2, 75. Don't forget the decimal. So if you make 5 cakes, you're going to use 7.5 cups of sugar. If you make 8 cakes, if we look on the graph, it looks like you'll use 12 cups of sugar. And I just picked things that were easy to spot on the graph. We could have used this point right here, where if you made 10 cakes, it'd be 15 cups of sugar. Or any other point that looks like it's on the graph. And you could tell exactly how many cups of sugar used by dividing your y value by your x value. So we could say 3 divided by 2. Oh, 3 divided by 2, that's 1.5. So for 1 cake, it's 1.5 cups of sugar. And because I can divide to find that answer, I know this is a multiplicative relationship. My multiplier is 1.5. My equation would be y equals 1.5 times x. There you go. Let's look at these next few questions about the same graph. Which of the following is true? A, the number of cakes is the dependent quantity because it depends on the amount of sugar used. No, that is not true because the number of cakes is on the x-axis. So that makes it the independent quantity. Let's look at B. The number of cakes is the independent quantity because it is represented on the y-axis. No, sugar is represented on the y-axis. That's not true. C, the amount of sugar used is the dependent quantity because it depends on the number of cakes made. This is true because if you don't make any cakes, you won't use any sugar. D says the amount of sugar used is the independent quantity is never going to be on the y-axis. So that's not going to happen. So C was the correct answer. The amount of sugar used is the dependent quantity because it depends on how many cakes you make. All right. So which function table correctly represents the graph? Same graph. If you make 2 cakes, you'll need 3 cups of sugar. If you make 1 cup, you'll need If you make 1 cake, you'll need 1.5 cups of sugar. That's on this table. Let's check the other things on this table. If you make 3 cakes, how many cups of flour will that be? Well, we can multiply 1.5 times 3 to figure that out. 3 times 5 is 15. 3 times, so that's 4.5 cups. So on this table, I see that 3 cakes would be 5 cups of sugar, which makes this table incorrect. Don't ask me why I chose 3. I just chose 3 because it was the first one here. This part is correct. And so that means if this one has one thing correct, that means this one has to be, or incorrect, that means this one has to be the correct answer. So when you're looking at a table to see if it matches a graph, you need to see if it's using the same multiplier or if those points are on the graph. Is the point 3 4.5 on the graph? Yes, it's right here. Is the point 4 6 on the graph? 4 6. Yes, it would be on the line right here. Is the point 1.5 on the graph? Yes, it would be right here. Is the point 7 10.5 on the graph? Yes, it would be right there. So it's on that line. That line is a continuum of amount of cakes versus the sugar used. So if there's something that crosses that line, then it's a point and it would be a part of our table. Okay, moving on. Let's look at another graph. Here, this one is about pizza delivery. What is this graph about? Pizza delivery. The bottom, the X horizontal axis, is the cost of the pizza. The Y vertical axis is the cost with the delivery fee. And you can see these points on the line. And of course there is a line through them, so there's points in between them. What is the independent variable? Ding, 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 ding. It's right here. The independent variable is always on your x-axis. Oh, the cost of the pizza. Okay. What is the dependent variable? The cost with delivery fee. I'm going to write that out as total cost. Looks like there's a delivery fee for that pizza. Can we make a function table with this? Absolutely. We look at these points that are on this line and we can find the coordinates that would be on that line. So this one right here would be 10 and looks like in between that would be 15. This point right here would be 20, 25. This point right here, and I'm going to have to draw through my things, would be 30 and 35. Oh, I think I know what the delivery fee is. Do you? Let's look at this last one. Would be 40 and 45. So we could use those points that are on that line to make our table. We could also determine that there is a point on the line here, maybe at 5 pizzas, it would cost Looks like maybe $10 almost. Yeah, 5 pizzas would cost you $10. All right. Oh, sorry, $5 for the pizza. So to make a table, we're going to call our x values, the beginning of our table, cost of pizza. And then we'll call our second half of our table, the independent part, with delivery fee. And we'll just put those points that are on the graph. We'll say if it's $10 for the pizza, it'll be $15 with the delivery fee. If it's $20 for the pizza, it'll be $25 with the delivery fee. If it's $30 for the pizza, it'll be $35 with the delivery fee. If it's $40 for the pizza, it'll be $45 with the delivery fee. So, what we have to decide is this additive or multiplicative relationship. Well, it's clearly not multiplicative because each time we're adding 5. 10 plus 5 is 15. 20 plus 5 is 25, and so on and so forth. So each time we're adding $5 to the cost of the pizza. So it looks like there's a $5 delivery fee. We could write the equation y, the total cost, equals x, the cost of the pizza, plus 5, the delivery fee. So there's your equation to go along with that table. Okay, so now which of the following is true? Same graph. The cost of the pizza is the dependent quantity. No, the cost of the pizza is on the x-axis. It's the independent value. B, the cost of the pizza is the dependent quantity because it depends on the delivery fee. No, we just got through saying it's the independent quantity. C, the delivery fee is the independent quantity because it's located on the x-axis. No, the delivery fee is on the y-axis, so that's not true. D, the delivery fee is the dependent quantity because it is located on the y-axis. Yes, that's true. We just said that. Okay. And then the function table that represents this graph, well, if the pizza costs $5 and you add $5 to it for the delivery fee, that would be $10. But if the pizza costs $80 and you add a $5 delivery fee for it, it is not $90. So this is not the correct. This is not the correct table. This, however, is the correct table because 80 plus 5 is 85. 5 plus 5 equals 10. 15 plus 5 equals 20. 60 plus 5 equals 65. I don't really like this table because it goes out of order, but as I've told you many, many times, you can put whatever you want on the table as long as it follows the rule. Here, the rule is plus 5. Okay? And that takes care of that. One more, just to help you out here. I want to ask you, think about the question. What is this graph about? Cost of gum. What's the independent variable? Well, whatever is down here on the x-axis, right? The pieces of gum is the independent variable because whatever's on the x-axis is always the independent variable. What's the dependent variable? Oh, the price of gum. So the price depends on how many pieces of gum you buy. That seems normal to you, doesn't it? Okay, so can we create a functional table from this? Absolutely. So we create our functional table. The first part of the graph has to be pieces of gum because that's our x value. That's our independent quantity. Pieces of gum. And the second half of our table has to be the price of gum. because that's our y values, our dependent quantities. So let's look at this table and let's just use the points that we can see quite obviously on this table. The first point would be the point 10 pieces of gum cost $1. So there we go. 10 pieces of gum, $1. If you buy 25 pieces of gum, it costs $2.50. If you buy 40 pieces of gum, it costs $4. I should make that $1. Okay. And then, of course, on the end of the table there, if you buy 50 pieces of gum, it costs $5. So think about this for a minute. Is this an additive relationship or a multiplicative relationship? Are we adding anything to the pieces of gum to get the price? Or are we multiplying the pieces of gum times a number to get the price? Think about it. If I can buy 10 pieces of gum for $1, that means each piece of gum is 10 cents, which could be written like this: 0 and 1/10. Now, you could write that as 0 and 10 hundredths, but it would be the same thing either way. So this is an multiplicative relationship. The thing that we're multiplying by is 10 cents. So our equation is y equals 0 and 1/10 times x. So there you go. There's a multiplicative relationship. I also know that it's multiplicative because it passes through the origin. That's an important thing. This is multiplicative because it passes through the origin. This, not multiplicative because it doesn't pass through the origin. Okay. So which of the following is true about this table? The pieces of gum is the dependent quantity because it depends on the price of the gum. No, the pieces of gum is down here on the bottom. It's the independent quantity. The pieces of gum is the independent quantity because it determines the price of the gum. Yes, that is a true statement. C, the price of gum is the independent quantity. Nope, the price of gum is on the y-axis. That makes it the dependent quantity. D, the price of gum is the dependent quantity because it's represented on the x-axis. No, it is not on the x-axis. It's on the y-axis. That's what makes it dependent. So, which function table correctly represents the graph? Remember, our multiplier is 10 cents. So if I buy 20 pieces of gum, it will cost me $2. If I buy 5 pieces of gum, it will cost me 50 cents. If I buy 55 pieces of gum times 10 cents, that'll be $5.50. If I buy 30 pieces of gum, that will cost me $3. So this table is correct. Let's see if this one is. 20 pieces of gum will not cost me 20 cents. So no, this table is not correct. So I hope this helps you with your other assignment that you have to do today. I hope to talk to you soon. I hope you're having a good day. Miss Elkins is out.